Okay, 2.3. We need to figure out how to tell the shape of a polynomial just by looking at the polynomial. So if I have x to, let's just do something simple, like x squared plus 2x minus 3. What overall shape does a quadratic have? It looks like a parabola, which is kind of a smiley face. Okay? So the shape is determined by this chunk. The rest of it kind of pushes and pulls and slides and everything like that. But that first term gives you the basic shape. And parabolas either look like smiley faces or frowny faces. What in the equation determines if it's a smiley face or a frowny face? The sign, this right here. So if that is a plus, then we have a smiley face. Okay? If that is a minus, then we have a frowny face. Does that make sense? What if it's minus 2 instead of just minus 1? That just changes the shape. So all positive x squareds are smiles, all negative x squareds are frowns. Okay? What if I had x to the third? What does it look like? It's the disco dance. I don't dance well. I don't dance at all. Okay? So an x to the third either looks like this or it looks like that. Okay? And we say that this is positive and this is negative. So when we're talking about an x to the third graph, we say it goes up or it goes down. Now, it's going to wiggle in the middle, but a positive x to the third is going down to the left and up to the right. Does that make sense? Yeah, it's like climbing up a mountain from left to right. You might do some ups and downs in the middle, but overall, as we go to the right, we're going up. Okay? So this is positive and this is negative. What about x to the fourth? X to the fourth can be a w. So it looks like this. It could also kind of look like a parabola, but we have happy w's, which are positive, and we have sad w's, also known as m's, which are negative. Does that make sense? What about an x to the fifth? X to the fifth is like x to the third, it just has more wiggles. This would be positive and this would be negative. So, all of the evens are happy or sad. Positive is happy, negative is sad. All of the odd exponents do the disco dance. Positives go up to the right, negatives go down to the right. Does that make sense? And then what happens in the middle? Well, we'll get to that, but for right now, all we're looking at are the endpoints. So looking at this assignment, okay, here we have several equations, and all we care about for this problem is this. The rest of it does affect the graph, but the basic shape is determined by the leading term. So, what is it about this that creates the shape of the polynomial? It's positive, right? The number in front of the 5 is positive, and the 5 does not affect the overall shape. It just kind of stretches it a little bit. Is equal. So 5x to the sixth. So we're focusing in on the positive. We're also focusing in on the 6. What does the 6 tell me? It's happy or it's sad. Right? This one is a positive 6, which means it's happy. And it's kind of like a W with an extra wiggle in there, so that would be a triple U. Right? So an x to the sixth is a triple U. But all we're focusing in on are the edges. So, rises to the left and rises to the right. Does that make sense? Okay. Good. If this was a 4, that just takes out one of the wiggles. This number is not important for this problem. Right? All we're looking at is positive or negative and then the exponent. Okay? So right here, what shape is B going to have? Well, it's negative and the exponent is odd. So it's a disco dance. So the left side is up and the right side is down because we're going down the mountain. Does that make sense? So rises to the left, oh, nope, and falls to the right. This one. Okay, the next one. This one's a little bit harder. How many x's are there? So 1, 2, but that second x is underneath a squared, so there are actually 3. And then what's the sign in the front? Positive. That's an equal sign, sorry. So this is the same as a negative x to the third, which is going to look like that. The 5 is, oh, sorry, positive. You were paying attention. Way to go. It's going to look like that because it's a positive x to the third. I said it wrong. So falls to the left, rises to the right. Do you guys want to see another set of these? You got these? Okay. Now I'm going to skip number 2 because number 3 is a little bit easier. So let's look at number 3. All right. So I have 2 equations and 4 graphs. And I need to figure out which graph matches the equation. So what can you tell me about, let's do this one first. Oh, sorry. Let's do this one first. How many x's are there? 4, right? 1, 2, 3, 4. Does everybody understand that? Okay. So we have an x to the 4th, which means it's either a w or an m. This one is a w because there is a positive right there. All right, so it's not an m. Now, what are the roots? So we want to know, when does this equal 0 and when does this equal 0? Well, this one actually factors into x minus, wow, that was terrible, x minus 1 and x plus 1. So what is the root for that? X equals 1. What is the root for this? X equals negative 1. And what is the root for this? X equals 3. Now, here's something that we haven't talked about before. If a root happens one time, then the graph just goes right through that number. Okay? So this root happens one time, this root happens one time, but this root actually has 2 copies. Right? So this is a double root. And a double root bounces. So it either bounces from the top or it bounces from the bottom. And it's going to take you a little bit of time to get used to this. So what we need to look for is a w that hits the x-axis at negative 1, at positive 1, and it bounces at 3. Is there a W that hits -1, +1, and then does a bounce at 3? A. So this is a W. It hits -1, check. It hits 1, check. And it bounces off of 3. So a bounce only occurs when you have a double root. You have one root that is listed twice in the equation. Okay? So that is A. Now let's look at the other equation. What can you tell me about this? It's a third power, which means it's a disco dance. And it's going down to the right. So it has to look something like this. And then the other thing you can always look at is what number is right there? 0. And if that number is a 7, then it hits the y-axis at 7. If that number is a -3, it hits the y-axis at -3. What if that number doesn't exist? It hits at 0. Okay? But this one's a little bit tricky because am I only missing the number? No, I'm actually missing the x and the number. So this one actually has 2 zeros, which means we have a bounce at 0. So we need to look for a negative disco dance that has a bounce at x equals 0. Okay? So it could... Yes. So whatever... so let's say this had plus x minus 2. The last number tells you where it hits the y-axis. And this one doesn't have a last number, which means it's 0, but this one is actually missing 2 numbers, which is kind of like a double 0. So it could be this one, maybe. It could be this one. Let's look and see if there's another one. Could it be E? Why not E? It doesn't bounce at 0. It goes straight through 0. So the answer would have to be C. So what was it? A, C, and A? So C and A. Okay, let's do another one of these. All right. So look at the top one. How many x's are in the top? 1, 2, 3, 4. So it's x to the 4th. Is it positive or negative? Positive. So what shape does it have? It's a W. Okay. And then what are the roots? -1 and 2. Are those single roots or are they double roots? They're both doubles. What happens at double roots? You get bounces. So is there a graph that is a W that has a bounce at -1 and a bounce at 2? E. Yeah, it's got to be a W, so it's going to be E. So that first one is E. Okay. Now the next equation, what shape does that have? Negative disco. Okay. And where does it hit the y-axis? At 0. Is it a single 0 or is it a double 0? How much of the equation am I missing? Just the single 0. So is there a negative disco that goes through 0. Not a bounce, but it just goes straight through 0. So what about A? Would A work? No, it's the wrong direction. That A is going up. F. Okay? So we got to keep doing these until I get one of the harder problems. Okay. I haven't done it yet. All right. Oh, try another. That's the same problem. No. Oh, good. All right, look at the first one. What shape does the graph have? Positive disco dance. And where does it hit the y-axis? 0. Double 0 or single 0? Single 0. So we need a positive disco that hits at 0. What about C? Nope, C's upside down. So it's got to be F. Okay. And then what type of graph is G? 1, 2, 3, 4. Cody, you're not wearing your mask. So this is an x to the 4th. Is it positive or negative? It's negative, which means it's an M. Okay. And what are the roots? Well, what's this root? 1. What's this root? 4. Now, good. So the first one is a single root. Single roots just go straight through the x-axis. Double roots bounce, but this one is a triple root. What do triple roots look like? Okay, they're a weird shape. A triple root looks like this. You get close to the x-axis and you level out, and you hit that point, and then you go like that. Or, if it's going the other direction, it would look like this. We kind of call those a saddle in mathematics. So a single root goes straight through the axis, a double root bounces off, and a triple root does a saddle. And a triple root is kind of like a bounce, only it doesn't actually bounce. So if I were to bounce, it would look like that, right? Well, what if you don't bounce? What if you just kind of reflect? So you come down, and then you go in the other direction like that. So it's kind of the same shape as the bounce, but it doesn't actually bounce. It just kind of slows down and then speeds up. Okay, so I need to find a graph that goes, it's an M, it hits x equals 1, and it goes straight through, and then we have this weird saddle at 4. Which graph would it be? It's an M that hits 1 and hits 4. And it's D. It's this graph right here. So we come up, we go straight through 1, and then we do this funny little saddle thing at 4. Okay, let's add one more piece to this. So this would be problem 2, or I guess it would be problem 5. Okay. Let's do 8, because I don't have anything written there. Okay. So we have to do all of those pieces and do the graph. And these are a little bit difficult. So how many x's are there? 1, 2, 3, 4, 5. So what is this going to look like? X to the 5th, what shape does that have? It looks like a disco with an extra wiggle in the middle. Okay, is it positive or negative? Negative, because of this. So the graph is going to look something like that. Does everybody understand that? Left side is up, right side is down. So I need to choose that option. Rises to the left and falls to the right. Okay. Now, where does it cross the x-axis? So x is equal to 2 and -1 and 1. But what happens at 2? Is it a single, double, or triple? 2 is a single. What about -1? -1 is a double, and 1 is a double. So here, these are the singles, and these are the doubles. So it asks you, what are the single roots? My only single root is a 2. What are the double roots? 1 and -1. Okay, now, it also asks us for the y-intercept. How do we find the y-intercept? It's just the number you get at the end. But there is no number at the end because this is in factored form. So we could multiply it all out, which is a huge pain. You could plug it in your calculator and graph it. There's an easier way. Just plug in 0 for x. And what that does is, it eliminates all of the x's, and then you just multiply all of these together. So what is -1 times -2? 2. -2 times 1 is still 2, but I have to do it again because there are 2 of them. So -1 or -2 times 1 is still 2, and then 2 times -1 is -2, but I have to do it again because there are 2 of them. -2 times -2 gives me +2. So my y-intercept is +2. So I type that in here. Okay, now for the hard part. What does this graph look like? And you need to draw it on your paper before you draw it on the graph, or you're going to get things all mixed up. So what do I know? I know that the left side is down and the right side, left side is up and the right side is down. So I know this and I know this. Does everybody understand that? Okay. What else do I know? I know there's a single at 2. That's a single root. I know there's a double root at -1 and a double root at +1. I also know that it hits the y-axis at 2. So these 4 points I know. Now I just play connect the dots. Okay? So I come down. What's going to happen when I get to that first root? Bounce. So I bounce and then I go through that point. What happens when I get to the next one? Bounce. And what happens when I get to the next one? Go straight through. And I have satisfied all of the pieces. So to graph that, and this looks really confusing, but once you get the hang of it, it's not too bad. So I need to put a point here, and then I have to choose the correct line. Straight through to the up, straight through down, bounce from the bottom, or bounce from the top. So this dot that I just put there is a bounce from the top, this one. And then I put a point on the y-intercept. Okay. And then I put a point on the x-axis at 1. And that one is a bounce from the top. and then I put another point at 2, and this one goes straight through from top to bottom. And then that point does not exist. Once I have all of those pieces, I touch the graph button, and that graph matches the one that I drew. Hey, I got it right. How nice. Let's do another one. Okay. How many x's do you see? 1, 2, 3, 4. So this is an x to the 4th. Is it positive or negative? Positive, so it's a w. Okay. And then, so I need to choose rises to the left and rises to the right. Any questions there? Okay. Are there any single roots? Both of these are singles. And the first one is -1, and the second one is -2. So I type those in. So -1, comma, -2. Okay. Do I have any double roots? 1 is a double root. And then y-intercepts, I just eliminate the x's. So I get rid of these x's. And I just times everything together. 1 times 2 times -1 times -1. That gives me y equals 2. So y equals 2. And now I draw the graph off to the side. So left side is up, right side is up. I have singles at -1 and -2. So both of those are singles. And then I have a double at 1. And then I have a y-intercept of 2. Then I just play connect the dots. So I come down, what happens at -2? Straight through, then I turn around, what happens at -1? Straight through, go through that, and bounce. And you can usually tell, well, you can always tell if you're doing it correctly, because if you do a bounce where you're not supposed to, then the y-intercept is going to be messed up. So if I come down and I bounce, and then I go straight through, now I'm below the axis, and I need to be above the axis. So that's usually a pretty good idea that you're in the wrong spot. If you bounced when you weren't supposed to, or if you went straight through when you were supposed to bounce. Okay. So let's draw that graph on this. So -2 needs to look like this. -1 needs to look like this. So there. Oh, I need to delete one of those. And there, and this one is a bounce. It didn't work. Okay, once I have all my pieces in place, I push graph, and then I can check it. Okay, get to work.